study about energy of a particle performing SHM. Consider a particle performing in SHM. It possesses energy at every point except at extreme position, where the kinetic energy of particle when its motion from mean position to extreme position, when the particle travels from mean position to extreme position, therefore its kinetic energy, the particle possesses kinetic energy and potential energy, therefore total energy is equal to kinetic energy plus potential energy. Kinetic energy of a particle performing in SHM, therefore kinetic energy is equal to formula half mv square. By using that formula, kinetic energy is equal to half mv square. But where v is the velocity of the particle performing in SHM, v is equal to omega square root of a square minus x square, and v is equal to plus minus omega square root of a square minus x square. Therefore, v square is equal to omega square in bracket a square minus x square. Taking square root, taking a square, therefore square and square root terms get cancelled, and v square is equal to omega square in bracket a square minus x square. Substituting that value, therefore we get the kinetic energy half m into omega square in bracket a square minus x square. But we assume that the force constant k is equal to, where k is equal to the force constant, k is equal to k upon m is known as omega square term. K upon m is equal to omega square. Therefore, k is equal to m into omega square. K is referred as k is equal to m omega square. Therefore, we get the formula for kinetic energy of a particle performing SHM. Therefore, kinetic energy is equal to half m omega square. That term can be used as k in bracket a square minus x square. The particle possessing a small kinetic energy as well as potential energy. If the particle is displaced from mean position to at point P4 point, therefore calculate the energy of the particle P at point P. Hence, its kinetic energy is equal to half k in bracket a square minus x square, and its potential energy is equal to potential energy. Potential energy is the stored energy. Stored energy, the particle displaced from a small displacement will be considered here. That displacement is dx. Therefore, potential energy is equal to work done. Is the stored energy. Therefore, potential energy is equal to work done. Work done is equal to restoring force or force into displacement. But here F is equal to F is the restoring force into displacement. Force into displacement. Therefore, restoring force is F into dx. But the restoring force and displacement are both in opposite direction. Displacement and force, restoring force, are move in opposite direction. Therefore, negative sign indicates minus a restoring force. F is equal to minus kx. F is equal to minus kx into dx. of kx dx. Therefore, integrating total work done when the particle displaced at point P. Therefore, the particle performing SHM, its potential energy means work is equal to half x dx is equal to x square upon 2 means half kx square. By using formula, integration of x dx is equal to x dx is equal to x square upon 2 k x square upon 2. Therefore, work done is equal to half kx square. Work done means potential energy. Therefore, potential energy is equal to half kx square. Half kx square. Hence, you can calculate the total energy of the particle performing in SHM. Total energy is equal to kinetic energy plus potential energy. Kinetic energy is equal to half k in bracket s square minus x square plus half k x square. Half k constant term, common term, a square minus x square plus x square. Therefore, square x minus x square plus x square get cancelled. Therefore, total energy is equal to half k square. Total energy is equal to half k square. Here denoted by total energy. K is constant. Half is the numerical value. Therefore, total energy is directly proportional to the square of amplitude. Hence, prove that total energy is directly proportional to amplitude square when a particle performing in a SHM. When particle performing, consider a particle performing in SHM. Draw diagram when the energy at point P. P can be energy of the P at the point P can be calculated. The energy every particle possesses, its movement due to its motion, it possesses energy. Kinetic energy is equal to half mv square. V is equal to plus minus omega square root of s square minus x square. Squaring v square is equal to omega square in bracket s square minus x square. Substitute that value in that equation. We get kinetic energy is equal to half m omega square in bracket s square minus x square. K upon m. We know that K upon m is substituted as omega square. In the previous lecture, therefore K is equal to m omega square. Kinetic energy is equal to half k in bracket s square minus x square. That equation can be obtained. And potential energy is equal to is the stored energy. Therefore, work particle displaced from with a displacement, small displacement dx. Therefore, it possesses potential energy. Potential energy is equal to work done. Work done is equal to force into displacement, but force is the restoring force multiplied by displacement. But force and displacement are moved in opposite direction. Hence, according to SHM, hence dw is equal to minus f into dx. F is equal to restoring force. F is equal to minus kx into dx. dw is equal to kx dx. Therefore, integrating on both sides, integration of dw is equal to integration of kx dx. X dx, integration of x dx is equal to x square upon 2. Hence, w is equal to half kx square. But work is stored in the